We're seeing an increasing demand for edge computing to drive new initiatives, whether it's AI-based processing, local video-based analytics, as well as rehoming applications and workloads that are just not applicable to run in the cloud or to be moved in the public cloud, whether it's due to network requirements, network reliability, latency needs, privacy, legal issues, data that shouldn't leave a particular premises, whether it's just the sheer volume of data that's being created by increasing digital sensors, video streams, so on and so forth. And that's all driving the need to be able to run applications close to where the data is being created, close to where users are interacting with the data, and then also deliver new applications and update those applications to all those remote locations in a efficient, timely, and reliable manner. Some of the challenges are just the sheer volume of the sites, and we work with customers that have tens of thousands of sites, running multiple applications at each site, with enormous amounts of data being aggregated. So being able to remotely monitor those systems, manage those, update those systems for security purposes, scale out those systems. The drive to the cloud, a lot of organizations have kind of forgotten that there's hardware underneath there. Even in the public cloud, there's hardware underneath that has to be monitored, has to be maintained, has to be replaced when it fails. If you need in an edge deployment all of a sudden to deploy a new application that needs a certain amount of CPU, RAM, and memory, being able to quickly deploy those out without necessarily sending expensive resources out to deploy that new infrastructure is a challenge. Being able to take what works in a lab environment and roll that out consistently across 10,000 sites is an enormous challenge. In a lot of these cases, they enable you to put the compute very, very close. So, unlike being restricted to a data center where you need, environmental controls, you need certain power restrictions, heat dissipation, so on and so forth, being able to have hardware that can be deployed very close to where the data is generated. Perhaps we have cases where we have customers that deploy small form factor computers with an application right into a manufacturing production line, like literally 10 feet away from the gear, because of the amount of data that the equipment might generate, because of the network requirements that would be required to even send that data back to a central data center in that location, much less send it out to a public cloud. The size, the cost is a factor. In many of these cases, the ultimate goal isn't just to have one edge computing platform in a location. It might be to have one per manufacturing line. We often find, and this is something our software enables, rather than buying one beefy, large, fortified server with redundant power, with redundant storage, redundant fans, we can take multiple small form factor systems, cluster those together, and get resiliency and reliability benefits much higher than an expensive fortified data center class server, but still put that out in the edge, put it in a more rugged environment, and be able to use the more cost-effective small form factor systems in those cases. One of the premises of the scale computing platform is the ability to scale out the system as your needs grow. So rather than investing and making an initial purchase decision to try to size and anticipate what your needs are for the application for the next 3 or 4 or 7 years or whatever your time frame is, working with SimplyNUC and their new generations of hardware, we can jointly provide customers the ability to buy what they need when they need it, knowing that they can add additional scalable resources and capacity down the line, whether it's for compute or whether it's for AI analytics. They can add the latest, greatest generation that's available 3 or 4 or 5 years down the line to that system, and then eventually just evict the older systems when their end of life is reached, and basically keep their IT infrastructure in an evergreen kind of manner. We're working very closely with the SimplyNUC hardware team to take advantage of some of the new capabilities, whether that's increased CPU resources. We're very excited about some of the new remote management capabilities, including built-in BMC remote management capability. We already do leverage the AMT capabilities on platforms that support that as well. And just additional use cases by being able to support ruggedized platforms, additional offload capability, GPU capability, and so forth will drive some of the new applications that we're both jointly addressing. Edge computing is essential because if you really look at the new applications that are delivering the business benefit, and they require the ability to do local processing in microseconds, to store data locally, to get information that they need out of that raw data, and then make instantaneous decisions on premises. We find that the customers that we deal with that are deploying their applications locally on premises do have a customer advantage to other organizations that adopt a strict cloud-first mentality. We've seen businesses that are able to operate through network outages, that are able to quickly adapt and deploy and provide new services on premises where customers are dealing with information or data, do have a strong competitive advantages to those who have one and only one way to build and deploy their applications. Looking forward at edge computing, we see, and most experts agree, just an enormous amount of new data-driven applications. So new sensors, consumption of data with things like AI and machine learning, doing local inferencing on increasingly large data sets. We see new hardware capabilities being built to drive those applications in a very cost-effective way and in different form factor sizes. And so we want to continue working with the Simply NUC team to make sure that we're collaboratively designing and requesting and integrating the right hardware and software capabilities to meet those needs for the future.